Hello, everybody. I am Dr. Felicity Millman, and I want to share with you some reasons we should begin to consider rethinking artificial intelligence and our automated systems to begin to understand some of the unintended consequences. But before I do, I want to say a giant thank you to our wonderful sponsors who are helping us be here today, wherever you are, physically, virtually, any time of day or night. Thank you. And I wanted to let you know a little bit about me to begin. So I originally did a PhD in psychology and genetics, which turns out means I'm a bit of a data nerd. And transitioning from there, I have recently, a couple of years ago, I went and got a master's in cybernetics, which basically means artificial intelligence and how we think about it. Went on to work in the Cybersecurity Institute as a threat caster, which means I work to try and understand where our future threats are going to come from and how we should mitigate them. And these days, I also do a little bit of teaching innovation for engineering and computer science, as well as building cybersecurity simulations that are actually inclusive for everyone, not just the cybersecurity professionals, but government people, policy people, your admin people, everywhere, for the National Security College at ANU. So, from that, given that we're all on country somewhere, I want to say a big acknowledgement to the traditional custodians of the land that I'm standing on at the moment. So that is the Whadjuk people of the Noongar Nation, as well as others in other places around us. There are so many to name that I can't remember, but thank you and acknowledging. So, why do we need to think about artificial intelligence and what actually happens with it? Well, I imagine when we think of technology in general, we don't always think of where it's going to go. So I imagine when the first steam engines were built, they didn't quite accidentally think that they might cause climate change by basically fueling their engines with fossilised trees and bits of animal bones. They didn't realise that they might create systems that would include huge amounts of pollution. But yes, we get pretty cool cars out of it. We also look at things like drones. We think, awesome, I get to take some really cool photos. Personally, I am a drone lover. I have done this myself. But it also enables us to have some quite scary weapons, like the one you can see in my hand there, as well as the big drones they have, or the swarms of drones that currently our technical systems struggle to manage, and that can perhaps not too long ago. And we also have things like our satellite technology. Dear old Elon Musk put a few up recently, and when I say a few, I mean a lot. And while that's great, it's connecting people all over the globe, it's actually kind of causing a few problems for our astronomers who aren't actually able to take pictures that they want to take to be able to understand where our world has come from. Bit of a problem there. So I guess it kind of makes us think technology is neither good nor bad. I think most people have kind of understood that. But the one thing that we often do forget is technology is not neutral either. So when we think of artificial intelligence, one of the things we often think about is data mining. It's how you make a lot of machine learning types of systems. You actually extract value from the data you create. Now, it really is an extractive process. Data mining is important. Something that we actually do well in Western Australia, and Australia in general, is mining. We do it well. Something that a lot of people don't realise about Western Australia is we actually have one of the most enduring histories of mining on the planet. I'm not just talking, a couple of thousand years. I'm talking a really long time. Hey, this is something we can actually learn from. So this is Wilgemia. It's a couple of 100 kilometres out of Mount Magnet. It's in the middle of Western Australia. It's a beautiful, beautiful place, but it's actually over 30,000 years old. It is one of the world's oldest mines. It has been used continuously for 30,000 years. Just think of that. The people who have been doing this created one of the largest networks on the planet. They learnt how to extract value from the ground and to transmit it and pass it between people and culture and to use it. They also created some really, really ingenious early safety systems where they would ensure that people had different layers so they could extract data from different places by having different pile systems. They actually built structures to ensure that the rocks weren't caving in and falling on them. It's pretty impressive when you think about it. And they also used regulations to ensure that their people and their community weren't going to be harmed. So they actually had rules about who could go in, who wasn't allowed in, when they could go in, and how they actually use data. And when we think about mining, this is a really, really good place to talk about it. We also have the largest robot on the planet. So the AutoHaul system by Rio Tinto is actually huge, if you've ever been fortunate enough to see it. It is an automated system. Mining is something we do well, whether it's been historically in the past or currently right here, right now in this space. This is something we do. Let's kind of begin to understand it a little bit better. What are we actually looking at when we're talking about automated systems and cyber physical systems? We know that everything has a context. We know that they're systems. Where is the human labour in all these artificial intelligence systems? Sometimes we don't talk about that. We also don't talk about sometimes where the physical resources are. How are we actually extracting value out of data? And how do we make sense of it? So, when we think about it, as I said, how do we make sense of it? Well, one of the first questions I think it's important to ask is, what is artificial intelligence? A lot of the time when I talk to technical people, they will give me some variation of data and networks and how we put them together, and there's a model, and these things are all technical and they're right. However, it's not the only thing. This stuff doesn't come out of nowhere. There are networks, there are cultures and contexts where this stuff is all coming from. So I actually think it's important that we recognise systems create artificial intelligence and our machine learning systems. And they are actually cyber physical systems. When we put these things together, we're talking about a whole structure of people and places and objects in a time and place. So, going back to how we make sense of it. Do we actually look at a component or do we look at the system? A lot of the time when we talk about artificial intelligence, I will hear people tell me about chips and how much storage they have and how much processing they have. We are really exquisitely good at taking a microscopic view. We go down into the tiny details to figure out how something works. Sometimes it might be useful to step back into view of a telescope, try and look out, what system is this part of? How does it connect to everything else? I think it's important to remember everything has a history and everything has a context. So when we're looking at systems, we need to look at, or when we're looking at machine learning or artificial intelligence, we need to try and understand where they come from. So again, it's looking at cyber physical systems. One of the big questions I like to ask is how something comes into being. How is it made? Where does it come from? Why was it made? One of the big questions I always look at is physical resources. And again, that's not talking just about your network cables and your hardware and your chips. It's actually talking about how they're connected. So I think this is important because the connection points can actually hint at where the inherent value is in the system. How we actually understand what we're extracting, what are we actually using here? One of the best examples I've ever seen of this was going back in history a little bit and looking at how our original networks were made. So these were the subsea cables, which were connecting all through the globe, connecting telegraphs. Now, on the screen, you can actually see they're cut-out sections of the original network cables. So, how are they made? Probably not something most people think about. Turns out, the original subsea cables, just like our modern cables, required insulation because, you know, seawater degrades things. It's something that previous generations actually had to grapple with. Turns out one of the best things they could insulate with was tree sap, so from the gutta percha tree, because it's naturally thermoplastic. So when you heat it up, it's all melty, and when you cool it down, it's quite rigid and stable. That's kind of cool, kind of interesting. So that kind of happened around 1820, 1830. They begin to figure out, hey, we've got something interesting. So one of the things about this tree, this very special tree, is it actually takes 30 years to reach maturity. One tree. It's kind of interesting. We've got some old trees around. 30 years doesn't seem that much. But how much sap do you think a tree makes? For one tree, not even a kilogram of their sap. So these blocks are some of the original blocks that were from the gutta percha tree. When it was processed, they cut them all up effectively boil them, then they process them, so they get off the stuff that's not actually the sap, and they turn them into these blocks that they then would extrude over the actual cables. So, just in this time frame, just a year, 3,960 nautical miles of cable were laid, and that was about 181 kilos of gutta percha. So if you do the maths, that's 1.2 million trees. 300 trees per nautical mile. Oof! In the 100 years that this stuff was predominantly used, there were and this is just one set of cabling, 315 nautical miles of cable were used, which equated to 47 million trees. And that's a conservative estimate. That's if we actually halve the amount of gutta percha they used on each cable, in case they were using some thin sections, some thick sections. So chances are over 100 million of these trees were used. Ugh! By one company in one country. That isn't even all the cables that run across the planet. So, guess what, guys? We made one of the earliest human-made disasters, human-made disasters, building our technological systems. Now, how did it come into being? We made it. We also need to recognise that when I say these connection points hint at the inherent value in the system, human labour was also involved in things. So there were workers in predominantly Malaysia and Borneo who were going out and cutting down these trees and initially trying to actually drain the sap out of them, then logging them and bringing them to ships and ports all over the globe. There were little kids in factories, often in England, who were cutting this stuff up, working with boiling tree sap. Not a nice job. Many of these people weren't paid particularly much money, and historically, if we look at where the value went, it was not to the workers, nor was it to the people whose land these trees were taken from. So, we know that a lot of these cables were actually made to points of strategic importance for colonies. So where these cables were being laid weren't necessarily going back to the people whose being cut down. They were often going between Europe and America, various European colonies. So even though we were taking all these wonderful trees and making these amazing systems, the value was not necessarily where we thought it would have been. But it hints at the value that was actually present in the system, and how it directed how it was actually built. So, worthwhile considering when you're building technological systems. Our cables and those values were not distributed evenly, not randomly. Worthwhile considering. So, the decisions of those people in the past are still impacting us today. Those network cables impact who has actual internet connection to this very, very day. We're in Western Australia, and I'm sure many of you will have either been in mining or dealt with mining or had to go out bush for some reason. Trying to get internet connection out bush, not fun. A couple of months ago, I was driving out to go on holiday and had the unfortunate experience of getting 60 kilometres out of Perth before I realised that I needed an internet connection to connect my sat phone. Turns out you've actually got to use the internet to connect a sat phone, and if you drive too far out, you can't do that. So those decisions far back then impacted my ability on to this very, very day based on where we've got connection points and where we've chosen to build our systems. So, recognising again, our technological systems have created ecological disasters. They have exploited traditional knowledge. But at the same time, they were the foundations of the Industrial Revolution. They've enabled us innovation. They've enabled us to be here right today, this very moment, talking to you in this room, talking to you wherever you are sitting on this planet. Technology isn't good or bad, but it does come very, very well entrenched in values. So, what about, again, human labour? I don't know how many people here have heard the story of the Mechanical Turk. A fair while ago, there was a person who decided he'd built a box and had told people that it could magically play chess without a human involved, and it was carted around Europe and said to be this amazing invention because it could play chess. However, turns out that what was actually inside, it was a machine, partially, but the machine actually contained a very small human who was a grand chess master who could actually move the little dials inside. So, the Mechanical Turk, and I admit, hideous name, but it's historically what the name is, kind of showed people, wait a second, some of our technical systems that we think are artificially intelligent, that we think are mechanical, that we think are smart, have people involved. Where is it? Where's it hidden? And often it is hidden. So, Amazon's Mechanical Turk system, the reason it is called MTurk is from Mechanical Turk, because what it actually is humans all around the globe who aren't paid particularly, may I say, who do repetitive, laborious and boring tasks for a very, very cheap price, which often startups, not looking at anybody in the room, build, or they actually use the MTurk system to get these tasks done, of which they then suggest it is actually artificial intelligence, just a human hidden somewhere else, to make these systems work. We also have situations where you are the human labour. How often do we actually think about the capture systems that we use? Because again, that is you training an artificial intelligence system, object recognition often, how to identify an object. Are you valuing your time? The company certainly is. And often these are already used on websites and services which you pay to use. Calling out PayPal. They certainly use capture. Again, they call it a security feature, but you're already getting charged in one sense. You're getting charged again in your labour. It's a choice that's being made. Again, it's hidden. They're not actually acknowledging that is what is happening here. We also have, again, our really, really large companies, Facebook, Google, Amazon. We certainly know, or I'm sure many people have heard the stories of the Amazon workers who are actually working in warehouses, who are picking and packing those objects that all of us have kind of ordered. Given we're in the middle of a pandemic, many people have ordered things online because it's easy, fair enough. But the people who are actually getting them are real humans who actually have to work to a very, very specific clock, the point being so specific that they actually expect high rates of injury because the humans have to work to the machine, not the machines working to the humans or their abilities, which is kind of scary when you think about it. All your data you put on Facebook and what you put on Google, again, these are used to train artificially intelligent systems. That is your human labour. Is it valued? We've also got data content moderators and data classification systems. What about the extraction process? So how do we get, I know that okay, we can get some data, that's great. But where does it come from? And how does it influence us? So we know our machine learning models are actually built from data. It has come from somewhere. As I said, where does the data come from? And where are those choices hidden? So let's talk about natural language processing because, that's an easy topic. We use words. Words are important. If you actually look back in history, some of the oldest oldest NLP models and the oldest data sets actually come from legal battles. So IBM's 1969 13-year legal battle and Enron's bankruptcy proceedings have actually been used to train a lot of our natural language processing systems. So again, if you trace things like GPT-3's data modelling back and back and back and back and back, you actually get to some of these places of where some of the raw input was initially put in. We have quantities of data. When we use these systems, do you think the way that you speak and the way that I speak reflects the words that are in those legal battles? I don't think I speak like a legal person at all times. I imagine I probably don't. Not only because I'm Australian, and let's be honest, we have a tendency for profanity, but because we also have our own culture, our own jargon that doesn't necessarily match the ones that have been used. We're repeatedly building on these systems. Our models are getting better and better and better, and we're getting further and further and further and further away from some of these systems, knowing where they've come from. Unfortunately, the assumption with these systems is language in them is unbiased and it's neutral. I would say it's probably not. So, what can that actually do? When we start looking at these systems, if we put automated systems in to, say, challenge if somebody is being rude or is it hate speech, it can often penalise people who don't come from the same background as where the data has been trained. So if you happen to be a bit of a sweary pants, sorry, some Australians, or you happen to be from Black African American culture, that one certainly happened. There tends to be higher rates of flagging for hate speech when it really, if a human moderators read it, it's not hate speech. This is a different culture and a different context that this information is actually coming from. Trying to begin to actually pull that apart, we need to actually understand where is our data coming from. How are we making sense of it? I think it's important to realise here that standardised does not mean objective. So just because a particular model might be standardised doesn't mean it's objective. So we may try and classify data by saying that's a cat and that's a dog, that's a boat, that's a pig. It's standardised. It's not necessarily objective. So we know that we can look at the output and say this is great. But where does the output come from? It comes from a model which is built from data, which that makes a fair enough amount of sense. Cool. But who actually gets to classify those images? Who gets to create the data? How do they do it? Do you know? Turns out a lot of the original data sets go back to those people who are working for Mechanical Turk. There are other ones which go back in other different ways, but these people live in different cultures, different contexts and different places and have been paid, again, not necessarily very much, to make these decisions that impact our lives right now. Do you call someone young, old? Do you give them a race? How about assigning their identity for them? I wonder if they like that. Worst of all, hot or not, back to Mark Zuckerberg and his famous initial experiment. Some of this stuff is being done for us by people in different places, making decisions that impact our lives. Some of the facial recognition data sets and some of those that are actually used by the US for their standardising situation by NIST, unfortunately, are actually made from people who did not consent. Often these people, many of them have actually died or were deceased when they took the photos. Think about that. And many of them were also convicted criminals, and these images were taken over time. It gets a little bit creepy when you think about that because they're devoid of context and meaning and story and personhood. What we consider a criminal now is not necessarily what was considered a criminal when some of these photos were taken. So unfortunately, people who may have done something just as simple as being gay was considered a criminal. They've ended up in a data set, whether that's okay or not, we've not looked at. It's certainly possible and it certainly happens. We're beginning to shift the way that we see images of data from single little objects to infrastructure. These are a resource, a data set that we can all go in and use, apply for opportunity to download the data set and train your model and off you go without actually recognising the humans who are involved. What happens if these models were built on your data? What about your baby photos? That's kind of cool. What about that really nice warm embrace you have with a friend? Or the last photo you've got of grandma before she died? How would you like them to be classified and who gets that choice? Well, if those photos are online, chances are they probably are already into those things. So, many object recognition systems are providing the backbone of our cyber-physical system. And yet we are not making the decisions or even considering where the voice of the creator is. What do your baby photos mean to you? What about Grandma's last photo? Who's got the right to use them? Can anybody use them? And how do they get to interpret them? What's actually interpreted? Is grandma's photo one that's tagged with love? Or just old woman, what about hot or not? It starts getting particularly creepy when you think about it like that. Everything has a history and a context. When we start separating a history and context from the data that we have and the systems that we use, we lose a lot. A lot of the meaning goes by the wayside, and it actually shifts the systems that we have, the world around us. So where are the choices we're making and how are they hidden? Data does involve choices. I hear a lot of people tell me, it's okay, it's standardized, it's objective. Well, I'd say it's not standardized, I'd say it's not objective, I'd say it's standardized. Because we are making choices which are prioritising one aspect in that photo over another. It may be tagging woman, it may be tagging ocean, it may be tagging sea, it may be tagging an emotion, but again, it's prioritising something over another. It doesn't give the meaning in the context. Things are excluded and things are included, and what is that? Who gets to make that choice? It impacts us all. All those models, when they build on the data and the systems and the structures, they reflect those decisions straight back to us. All of those photos I showed in the previous example were not photos of real people. They were actually photos from a GAN, which actually created people. If you go back and look at those photos, you'll notice most of them are of a certain skin tone, and you'll also notice gender and culture, more commonalities than others. That doesn't necessarily reflect humanity. That reflects the data that the system was trained on. So what we're looking at is a lot of subjective choices that are being made every day for us. Again, everything has a history and everything has a context. These cyber-physical systems really are systems. They are structures, they are processes and people. We know these things are important. How can we adapt to them? I hear a lot of people getting quite upset when they hear some of the awful things that some of our artificially intelligent or machine learning systems can do, from things like deepfake porn being one that is just particularly creepy on a huge number of levels, to some really creepy Twitter bot or kind of Twitter creations where we have bots who kind of swear back at us and do some awful things. A lot of people say, regulate it. I love regulation. This is great. We can just make it not do that, because regulations will just stop everything. And while I really like the idea, kind of don't think it actually works. But even if it does, well, what are we going to do? We know there's things that we don't want our systems to be. We don't want them to be machine-driven. We don't want those people in Amazon warehouses having to move exactly to the machine, their entire lives being driven by those machines. We know that we don't want our lives controlled by machines around us, or I certainly don't. We want trustworthy, safe, reliable systems. So how do we build them? Well, in Australia at the moment, we have an AI ethics framework where some of these values are stated, how we build systems and what should we be trying to build them to. That seems pretty fair to me. I like the idea. But regulations, just like our data, just like our models, are decisions. They're prioritising people, or they're prioritising what is important for a certain group of people at a certain place in time. They are not objective. The world is messy, it's complex, and it's always in flux. Things are changing. You're changing, I'm changing. I hope you all learn. I hope the person that you are yesterday is different to the one you are tomorrow. I hope you're not the same person you were when you were 3, because that'd be weird. But it's something we need to recognise. The world is messy, it's complex. So are cyber-physical systems. How do we adapt them? Well, those regulations need to adapt to changing systems. What is it within our regulations that allows us to go back and say, well, you know, we put in this rule, it didn't work very well. Maybe we could try something else. We know that if we don't have enough regulation, it leads to harm, and that's how we end up with some pretty dodgy systems. So my mind immediately goes to the deepfake porn situation because it is just so abhorrently awful. We know those things can happen. So if we don't do something about it, that's a really predictable harm, and we know we should probably do something about that. But the other thing we need to recognise is over-regulating can actually cause some significant problems too. It has the capacity to solidify structures, people, processes and decisions that aren't necessarily good. So I know that within the lifespan and the living memory of people, some of whom may be here today, an Indigenous person was not considered a human. 1960s, I think that was changed. It's kind of scary. Certainly within my lifetime, I think, being gay, lesbian, LGBTQI, anything under that banner was considered actually an illness or a disease in the Diagnostic and Statistical Manual for Psychologists, Psychiatrists, Doctors. And it was made illegal in our legal systems. So if we run regulations completely solid and we don't recognise change, we can actually start putting in values in place which maybe aren't so good for us. This also means we can over-optimise systems, because I think a lot of the time when we talk about regulations, the concept of regulation or rules can go not just from the way that our society makes decisions, but how we build companies and how we build teams and how we build data sets. So if all of your data sets or all of your data comes from one gender, one age, one particular skin tone, chances are if you try and release it in a different place in the world, that system will break, or it will be biased, or it will be just flat out wrong. The same goes for organisations, people, governments, regulations. If we actually only make systems that can only take into account such a tiny little thing, systems break. We actually need flexibility in systems. We need space for thinking. We need diversity. We need people to have the opportunity to see difference. When we start making the reins of what we do tighter and tighter and tighter and tighter and tighter, we can actually cause harm. Again, our systems are created. They're based on decisions that prioritise. We change. So do our systems. Let's actually try and make sense of the change rather than pretend that it doesn't happen. How do we do that? We bring in diversity. Diversity actually straddles the line between fragility and chaos. We know our systems need to be robust enough that they can cope with a little bit of change. So we need rules and regulations, but they've got to be flexible enough that they can take into account unexpected changes, because if we don't, we make dangerous things. When we're talking diversity, we need data, ideas, experiences, and people. We need it at all levels. So why should this really matter to you here today? Because most people think that's a really nice idea, I like diversity, that's great. And yeah, human labour makes an impact on what we build, and yeah, sometimes it's hidden, and physical resources also really count, but why should it matter to you? Well, WA, Australia, we are actually at the epicentre of where some of the physical resources that build our cyber-physical systems come from. So in WA, we produce 41% of the global supply of lithium. If you actually have a device that requires a little battery, or you happen to be cool enough to have your Tesla car, I will get the word out, what we're actually seeing is they actually have lithium in the batteries. So all these systems require lithium. We actually supply that. Many of these devices also require rare earth metals. That comes from right here in Western Australia. Just as a bit of an aside, one of the major owners of one of the companies who actually build some of this is an Australian. Mineral Resources does a huge amount of lithium mining, owned by our very own Australian farmer, who is making decisions about where money is spent, what information is shared, who gets to hear what. These decisions matter. Again, look, This is what happens when I click buttons wrong. Sorry, everybody. As technologists, designers, just general citizens, as people, as regulators, you get to make choices that change this world. And those tiny little choices about what data is included or excluded, which models you use, where does it come from? You can actually choose to make the world better or not. That is up to you. So, how are the choices you're making influencing the world? How are you looking at your human labour and the human labour of the people who contribute to these systems? How the environment, the raw resources in our own environment, impact on the supply chain that goes along, not just for us now, but for people in the future. Where is it all hidden in the process? Where is the feedback? How do we actually understand what happens to these things? Because at the moment, these are discussions we don't seem to have as often as maybe we could. I think it's worth it. Thank you.